Hello students, I am Satish Hegde, Assistant Professor, Department of Mathematics, Canara Engineering College, Mangaluru. So far we have discussed first order, first degree differential equation, that is ordinary differential equation, in which we have taken exact, reducible to exact and Bernoulli's equation, and also we have seen the applications of differential equation of first order and first degree in orthogonal trajectories, Newton's law of cooling and flow of electricity. Today's session we take non-linear differential equation, that is equation of first order and higher degree, whereas we are taking here equations solvable for P. So equations of first order and higher degree. For example, if suppose we have equation say dy by dx the square plus x dy by dx plus xy equal to 0. Here the equation is of first order but it is of second degree. Here also we have a first ordered second degree differential equation, y dy by dx the square plus x minus y dy by dx minus x equal to 0. So we take dy by dx equal to p. Here onwards we write the equation by taking dy by dx equal to p. So let me assume dy by dx equal to p. Then the differential equation is of the form f of x comma y comma p equal to 0. So that means altogether this is a function of x, y, the variable x and y, where x is a independent variable, y is a dependent variable, comma the derivative dy by dx, we denote it as p. Now let me take first order higher degree equation. If it is solvable for p, the equation is solvable for p, how to solve it? So whenever equation solvable for p, if I take a general equation of nth degree first order, then the equation will be of the form a nth degree first ordered equations of the form p power n plus p1 p power n minus 1 plus p2 p power n minus 2 plus etc. pn equal to 0, where p1 p2 pn the coefficients are functions of x and y, and the small letter p, as you know, it is nothing but derivative of y with respect to x, dy by dx. Now here clearly it is equation in p nth degree, in terms of nth degree. So it is a nth degree equation in p. So I can say it is solvable for p. So first of all we have to factorize it. Obviously there will be n factors. So let me split this up to n linear factors. So we will get p minus f1 of x comma y into p minus f2 of x comma y, etc. p minus fn of x comma y equal to 0. So each factors equate it to 0. The next step is each factor we have to equate it to 0 and solve it. So we'll get, on solving we'll get obviously n solutions. So that is f1 of x comma y comma c equal to 0, f2 of x comma y comma c equal to 0, and fn of x comma y comma c equal to 0, where c is the integral constant, arbitrary constant we have to choose. So now the solution of this equation nth degree first order differential equation is just take the product of these solution. So solution of nth degree differential equation constitutes the product of these solution. So that means we can say the general solution is f1 of x comma y comma c into f2 of x comma y comma c, etc. into fn of x comma y comma c equal to 0. So whenever we find a equation second degree or third degree quadratic or cubic equation in terms of p, The method is simple. So we have to first factorize it, find the factors, equate each factor to 0 and solve. We will get solutions of each factors. So finally the general solution is nothing but the product of these solutions equal to 0. So let me now take problems on this equation solvable for P. So we will take the first one, dy by dx the whole square plus 1 minus x dy by dx minus x equal to 0. So we have dy by dx the first order and degree is 2. So first step is we rewrite this in terms of P by taking dy by dx equal to P. Therefore the equation now becomes P square plus 1 minus x P minus x equal to 0. So student, just observe, this is a second order equation in P, correct? It is a quadratic equation in P. So we have to first factorize it. So the factorization is just by splitting the terms. So P square plus P minus xp minus x equal to 0. So once we split this, so it is easy to find out the common factors, the first and the second. So what are the common factors here? In the first and the second, the common factor is P. So by observing this, I can write P into P plus 1. So once we got P plus 1 is common, so try to extract P plus 1 from this. So write directly P plus 1. So then what left out from this third term, minus x is out. So you write it minus x. So check whether it is satisfy the third and the fourth term. Minus x into P minus xp minus x into plus 1 is minus x. So that means, so we can get P plus 1 and P minus x are the factors. So we have written P plus 1 into P minus x equal to 0. So the factorization is over. Now what the next step? The next step is each you have to equate it to 0. Equate it to 0. So we have P plus 1 equal to 0 as well as P minus x equal to 0. So simultaneously you can solve these two equations. Now rewrite P means what? Dy by dx. P is dy by dx. So I have the equation dy by dx equal to minus 1, another is dy by dx equal to x. So it is a first order, first degree differential equation, ODE, ordinary differential equation. So which we can further solve by checking whether it is variable separable. If it is variable separable, directly you can solve. So here dy by dx, can write dy is equal to minus dx, here dy is equal to x dx. So integrate on both sides. So on integration, so what we get, so here y is equal to minus x plus integral constant c. Here y is equal to integral of x is x square by 2 plus c. So rewrite this, it is y plus x, or you can write minus x minus y plus c equal to c, and here it is x square by 2 minus y plus c, or if you take 2 common, multiply throughout, then you will get x square minus 2y plus 2c or some capital C constant. So we have finally the general solution is the product of this. So I have y plus x minus c, that is x plus y minus c, and another is x square minus 2y plus 2c, but I have taken some new constant. So here these two are same, the arbitrary constant should be the same because it is first order differential equation. So your general solution must contain one arbitrary constant. As you know, the general solution consists as many as arbitrary constant as that of order of the differential equation. So we move on to the next. So we have dy by dx minus dx by dy equal to x by y minus y by x. So first I can write dy by dx is nothing but p, that's why dx by dy means 1 by p. I written p minus 1 by p is equal to x by y minus y by x. on simplification, so if you take the LCM, it is p square minus 1 whole divided by p, or that p you can take this side, so that becomes x by y minus y by x into p. So that means p square minus this, you can take that side, so this becomes plus y by x, this becomes minus x by yp. So I have plus y by x minus x by yp minus 1 equal to 0. So it is a quadratic equation in P. So factorize it as usual. So we have 4 terms. From the first and the second we have P common. So I have P common means P into P plus y by x. That P plus y by x you can take it from the second, correct? So what is that? P is common from the first. I have p plus y by x, p plus y by x, p plus y by x. So I'll write p plus y by x. From the third and fourth term I have to get this p plus y by x. Am I getting p plus y by x? We have to check. So I'll check that. So here minus x by yp, and here it is minus 1, correct? So I have minus x by y common. By third term I can observe minus x by y. If I write minus x by y, so I have minus x by yp, that is correct, third term. But I want minus 1, is it that correct? Minus into plus minus, x by y into y by x, that gets cancelled, it gives minus 1. So that's why p plus y by x into p minus x by y, p minus x by y, these are the factors, so equal to 0. So next, each factor you equate to 0 will get 2 equations. Further we have to solve that. So I have p means dy by dx, so dy by dx equal to minus y by x, and dy by dx is equal to x by y. So first order, first degree differential equation. So that means x dy plus y dx equal to 0. Here x dy minus y dy equal to 0. So integrate. So this is nothing but actually direct derivative. So x dy plus y dx. So what is that? X dy plus y dx is nothing but d of xy. Product rule. So it is a direct derivative of xy. First function x into derivative of y dy plus second into derivative of first y into dx. So x dy plus y dx is nothing but d of xy. Integrate on both sides, so we'll get xy is equal to c. That's how we got xy equal to c. So this is a variable separable, directly you can integrate. So x square by 2 minus y square by 2 is equal to c, or if you take multiple of 2 together on both sides, so it will give x square minus y square equal to 2c, or we have written a constant c, capital C, or some new constant. So both sides we have the same constant. So finally what is the solution? So here we have xy minus c equal to 0. Here x square minus y square minus c equal to 0. So the product of these two constitute the general solution of the given equation. So that means the general solution is xy minus c into x square minus y square minus c equal to 0. Correct? So we got the general solution for the given equation as xy minus c into x square minus y square minus c equal to 0. So let us move on to the next problem. So here y dy by dx the whole square plus x minus y dy by dx minus x equal to 0. Solution. As usual, we rewrite dy by dx as p. So we get yp square plus xp minus yp minus x equal to 0. Factorize. So we have p is common, so yp plus x. So from this yp plus x, if I take it out, so remains minus 1. So the factor is yp plus x into p minus 1 equal to 0. So and hence we get yp plus x equal to 0 means y is equal to minus, or sorry, p is equal to minus x by y, but p is nothing but dy by dx. So we have a ODE dy by dx equal to minus x by y. Similarly, P is equal to 1, that is dy by dx equal to 1. So I have y dy and minus x dx. Take it to one side. So it is x dx plus y dy equal to 0, and here it is dx minus dy equal to 0. Solving, so we get integrate on both sides. This gives x square by 2 plus y square by 2 equal to c, or x square plus y square equal to c. Here it is x minus y equal to c. So take the product. So we get the general solution as x square plus y square minus c into x minus y minus c equal to 0. Is it that correct? So we take one more problem. P into p plus y is equal to x into x plus y. So here we have p square plus py equal to x square plus xy, or I can write it is py minus xy plus p square minus x square equal to 0. So that I can factorize by selecting first two terms. The common is here y. So we have y into p minus x. From the third and the fourth, p square minus x square, you can rewrite it as p plus x into p minus x, so that p minus x is common over here. So p minus x into p plus x plus y equal to 0. So equate each to 0. So we'll get p minus x equal to 0, that is p equal to x, or dy by dx equal to x. Another is p is equal to minus x minus y, or minus of x plus y, that is dy by dx equal to minus of x plus y. The first one is a variable separable, so I have x dx is equal to dy, whereas the second one is not a variable separable. So here if you observe that, rewrite, that is dy by dx plus y equal to minus x. So this is clearly a linear differential equation. As all of you know, the linear differential equation, the standard form, dy by dx plus p of xy equal to q of x. So this is linear in y. So how to solve linear differential equation, student? So first you get the integrating factor, that is e power integral of p of x dx, the coefficient of y, dependent variable. So identify that. So integrate, and e raised to that is the integrating factor. So once the integrating factor is obtained, the general solution, we have y into integrating factor, that is dependent variable y here, into integrating factor equal to right hand side function, you multiply with the integrating factor and integrate. So thereby integral of q of x into integrating factor dx plus integral constant c. So if I solve both the equation, the first one is by direct integration, so it gives x square by 2 equal to y plus c. The second one, for that we have to find the integrating factor. The coefficient of y is here 1, e power integral of 1, that is x, so e power x. So multiply dependent variable by integrating factor, y e power x is equal to, so what we have, y e power x is equal to integrate right hand side function multiplying with the integrating factor. So I have minus of integral of x e power x dx. So integral of x e power x is x minus 1 e power x plus integral constant c. So throughout dividing by e power x, I can get y is equal to minus of x minus 1 plus c e power minus x. Or the general solution, we can write the product of these two, that is x square minus 2y, sorry, here it is a correction, it should be 2y, okay, x square minus 2y minus c into x plus y minus 1 minus c e power minus x equal to 0. So let me take one more problem. So we have xy p square minus of x square plus y square p plus xy equal to 0. So obviously this is a quadratic equation in p. So factorize it. Xy p square minus x square p minus y square p plus xy equal to 0, 4 terms. So we can easily factorize it by identifying the common from first and the second, that is xp is common. So left out is yp minus x. So from the third and fourth I'll write yp minus x. So what is left is here minus y, just write minus y into yp minus x, so that gives xy, minus of minus plus xy. So the factors are yp minus x into xp minus y equal to 0. Equate each to 0 and extract the differential equation. So here we have dy by dx equal to x by y, that is yp is equal to x, or p is equal to x by y, p means dy by dx. Similar way, xp is equal to y, p is equal to y by x, so dy by dx equal to y by x. If you rewrite, then it is x dx minus y dy is equal to 0. Separate the variables here. 1 by x dx is equal to 1 by y dy, or 1 by x dx minus 1 by y dy equal to 0. Both are in variable separable form. So directly we can get the general solution by integrating on both sides. So integral x square by 2 minus y square by 2 equal to c, or you can write x square minus y square equal to 2c, that is a new constant c, capital C. Integral on both sides we get log x minus log y, since both are in log, so write constant also in log, so log c. So on simplification it gives actually log m minus log n is log m by n, that is log x by y is equal to log c, both side log gets cancelled, x by y equal to c, or x is equal to cy. So hence the general solution is now product of these two, x square minus y square minus c into x minus cy equal to 0. So we take the next problem. So dy by dx the whole square plus x plus y dy by dx plus xy equal to 0. Right, in terms of p, the given equation is now p square plus xp plus yp plus xy equal to 0. Let us factorize. So p into p plus x, here y into p plus x equal to 0. So that means the factors are p plus y into p plus x equal to 0. We get two first order first degree differential equation is dy by dx equal to minus y, or dy by dx equal to minus x. So that is minus 1 over y dy is equal to dx, or 1 over y dy equal to minus dx. Here minus x dx equal to dy. Separate, we have separated the variables, so on integration we get log y is equal to minus x plus c, or we have written here k, any constant, but take constant common in both the equations. Y is equal to minus x square by 2 plus k. So y here is log, you can take this side, so that gives e power minus x plus k, or e power minus x plus k. You can write e power minus x into e power k. E power k is c. So I have written y is equal to c e power minus x, or y minus c e power minus x. So here if I take simplification, on simplification it gives x square plus 2y minus 2k, that is 2k I have written it as c. So x square plus 2y minus c equal to 0. So this is the required solution of the given equation. Next, so here we have a quadratic equation again, x square p square plus 3xyp plus 2y square equal to 0. Now so far we have seen that 4 terms were there, so that factorization we can immediately take that factorization easily by observing from the first two terms the common term, and third and fourth we can extract the common term, but here we have to split. So 3xyp I can split such that xyp plus 2xyp, correct? So we got that, we know that basic concept. So the product should be equal to x square 2y square 2x square y square, the product should be equal to 2x square y square, correct, 2x square y square p square, and sum should be 3xyp. So if I write this xyp plus 2xyp, the product is 2x square y square p square, and sum is here 3xyp. So I have taken that into 4 terms. Now you can observe the common terms here. It is xp common. So I have xp into xp plus y. So from this and third and fourth, I'll write xp plus y common. So what we need to multiply is 2y. 2y is the term left out. 2y into xp, that is correct, 2xyp, 2y into y, 2y square. So that means the factors are xp plus y into xp plus 2y equal to 0. Now solve by equating each to 0. So we have xp is equal to minus y, or x dy by dx equal to minus y. Here x dy by dx equal to minus 2y. Separating the variables and then solving. So I can write it as 1 over x dx equal to minus 1 over y dy, or 1 over x dx plus 1 over y dy equal to 0. So the variables are separated over here. Similar way here also I can write it as minus 2 by x dx is equal to 1 over y dy, or that is 2 by x dx plus 1 over y dy equal to 0. So both are in variable separable form, so that the solution is just by integrating on both sides. This gives log x plus log y equal to c, or log m plus log n is log mn. So log xy equal to log c. This gives xy equal to c. So here it is 2 log x plus log y equal to c, or 2 log x, that is n log m is log m power n, that gives log x square plus log y together log x square y is equal to log c. Both side log gets cancelled. Xy minus c equal to 0. Here x square y minus c equal to 0. Hence the product of this is the general solution. So the required solution is xy minus c into x square y minus c equal to 0. Shall we move on to the next problem, students? So I have here p square plus 2py cot x equal to y square. So this problem is very important. So here it is a quadratic equation, but in order to solve this, so we, instead of using the Sridharan formulae, we just try to factorize by adding suitable terms. So if I closely observe this, so in order to complete the square, so it is p square plus p into 2 into p into y cot x. So y cot x, your term like b, it is a square plus 2ab, b is y cot x. So adding y cot x the whole square means it becomes a perfect square. A square plus 2ab plus b square can be written as a plus b the whole square. So thereby I can write p plus y cot x the whole square. So therefore we take adding y cot x the whole square on both sides. So if I add y cot x the whole square on both sides, what it gives? See here, p square plus 2py cot x plus y cot x the whole square. Right hand side also we have to add y cot x the whole square. So y square plus y cot x the whole square. So this is the perfect square. We can write p plus y cot x the whole square is equal to y square is common over here. So y square into 1 plus cot square x. We know that identity, cosec square minus cot square x is 1. So 1 plus cot square x is cosec square x. So we have y square cosec square x. So that means we get p plus y cot x the whole square is equal to y cosec square x. So what is then p plus y cot x taking square root. So we'll get p plus y cot x is equal to plus or minus y cosec x. So we have here then two equations. One is p plus y cot x equal to y cosec x, or p is equal to minus y cot x plus y cosec x. The second one is p is equal to minus y cot x minus y cosec x. Both we need to solve further. So we'll take one by one. The first one, p is equal to y cot x, sorry, minus y cot x plus y cosec x, or y cosec x minus y cot x. So p means dy by dx. So one equation is here, dy by dx equal to y into cosec x minus cot x. So now we can integrate by separating the variables. This is a variable separable form. You can write dy by y is equal to cosec x minus cot x dx. So 1 over y dy integral is log y. So here we have cosec x integral as well as cot x integral we did. So cot x integral, we know that it is log sin x, but already we have minus sign outside. So cosec x integral, either you can write log of cosec x minus cot x or minus of log cosec x plus cot x. So here we take minus log of cosec x plus cot x, so that we can simplify easily by taking these two logarithm term to right hand side. So which simplifies easily. So we can write it is integral of cosec x is minus log of cosec x plus cot x minus cot x integral is log sin x, plus I write constant as log c, both side in terms of log, then better to write in terms of log, the constant also in terms of log. So take this to left hand side, we have log y plus log cosec x plus cot x plus log sin x. So logarithmic rule gives now log of y into cosec x plus cot x into sin x, both side log gets cancelled. So y into cosec x plus cot x into sin x, multiply sin x to this, cosec into sin is 1 by sin into sin, that is 1, plus cot x into sin x is cos x by sin x into sin. So sin cancel, so it gives 1 plus cos x. So y into 1 plus cos x is equal to c, that is one of the solution we got. So further we need to solve one more equation, that is p is equal to minus y cot x minus y cosec x. So that means dy by dx equal to minus y of cosec x plus cot x. So again by separating the variables, then we integrate. So what it gives, 1 over y log y, 1 over y dy, 1 over y dy, integral of that is log y. So remains here minus cosec x minus cot x. So minus cosec x, that is minus sign is already outside, so that's why I write cosec x integral is log of cosec x minus cot x, minus cot x, integral of cot x is log sin x. So here we have taken minus of log cosec x plus cot x, but here minus since already there, so integral of cosec x I write log of cosec x minus cot x, so that the simplification becomes easy. So we can move this to right hand side, become log m plus log n, formula we can add log mn. So again the same method, so log on both sides gets cancelled, y into cosec x minus cot x into sin x. So cosec minus cot into sin gives 1 minus cos, so y into 1 minus cos equal to c. So finally we can combine these two solutions together, we can write y 1 plus cos x equal to c and y 1 minus cos x equal to c. We can write the general solution together as y into 1 plus or minus cos x equal to c, because we have the same term 1 plus cos x and 1 minus cos x. So I write 1 plus or minus cos x equal to c. So students, please concentrate on this problem because it is slightly different from what we have seen so far. So just by adding a suitable term on both sides, so it is clearly visible why we have added y cot x the whole square, because just to complete the square. So take the next problem. Now here we have a cubic equation. So third degree equation, which we can solve by again factorization method. So factorize it. So I can observe the first two terms, p square is common. So the given equation is p square into p plus 2x. So from third and fourth I will extract p plus 2x. If I write p plus 2x, what left out is minus y square p. So write that minus y square p and check whether it satisfies the fourth term also, minus y square p into plus 2x, plus into minus minus 2xy square p. So that means the factors are here p plus 2x into p square minus y square p. So p square minus y square p, again p is common, so p into p minus y square into p plus 2x equal to 0. So third degree equation, obviously we expect 3 factors. We got 3 factors. The one is p equal to 0, another is p equal to y square, and the last one is p is equal to minus 2x. Equating that to 0, we got these 3 equations. So p equal to 0 means dy by dx equal to 0, dy by dx equal to y square, or dy by dx equal to minus 2x. All 3 we have to solve. So that gives y equal to c. From this I can write 1 over y square dy equal to dx, variable separable, integrate on both sides. 1 over y square integral is minus 1 over y is equal to x dx integral, sorry, 1 over y square dy equal to dx, integral of dx is x plus c. Here we have dy is equal to minus 2x dx. So integrate on both sides. 1 integral of 1 with respect to y is y, minus 2 times integral of x is x square by 2. So 2 cancel, minus x square plus c, or the product which we have here is y minus c, and here if you multiply the root by y, you will get xy plus 1 plus cy. So x square plus y minus c. So totally we have the general solution is y minus c into xy plus 1 plus cy into x square plus y minus c equal to 0. I hope you understood. So one equation where we have taken a cubic. Similar manner we can solve cubic equation also. Next. So just observe here. So we have quadratic equation p square plus 2p cos hyperbolic x plus 1 equal to 0. Here this problem we first write cos hyperbolic x in exponential form. We know that cos hyperbolic x is e power x plus e power minus x by 2. So 2 cos hyperbolic x is nothing but e power x plus e power minus x. So the given equation now becomes p square plus p e power x into e power x plus e power minus x, p into e power x plus e power minus x, or p e power x plus p e power minus x plus 1 equal to 0. So from the first two terms I can take the common p. So left out is p plus e power x. From the third and fourth, if I extract p plus e power x, so what expected is e power minus x is common here. So just observe e power minus x into e power x is e power 0, that is nothing but 1. So that means p plus e power x into p plus e power minus x equal to 0. The factors are p plus e power x, p plus e power minus x. Equate each to 0, we get first ordered first degree differential equation dy by dx equal to minus e power x and dy by dx equal to minus e power minus x. Both we can separate the variables and then integrate. Dy is equal to minus e power x dx or dy is equal to minus e power minus x dx. On integration we get y is equal to minus e power x plus c, y is equal to minus integral of e power minus x is e power minus x by minus 1. So minus of minus becomes plus e power minus x plus c. So the general solution is y plus e power x minus c into y minus e power minus x minus c equal to 0. So similar type of problem we'll take one more where we have sine hyperbolic x. So this is again the same way. Write sine hyperbolic x in terms of exponential. As you know, sine hyperbolic x is e power x minus x by 2. So p square plus 2p into e power x minus x by 2, 2 gets cancelled. So p into e power x minus p into e power minus x. So these we have to factorize. P is common, p plus e power x minus, so write p plus e power x, what left out is minus e power minus x. So minus e power minus x into p, that is a third term, minus into plus minus e power minus x into e power x is e power 0, that is 1 minus 1 will get. So that means the factors are p plus e power x into p power minus p minus e power minus x equal to 0. Equate each to zeros, will get, after separating the variables, dy is equal to minus e power x dx dy by dx is e power minus x or dy is equal to e power minus x dx. On integration, the solution we get is y is equal to minus e power x plus c. Here integral of this is y is equal to integral of this is minus e power minus x plus c. Or the general solution, I can write y plus e power x minus c into y plus e power minus x minus c equal to 0. Student, hope you understood the method to solve whenever the equation is given in the form solvable for P format. So one can get the solution as explained in this video. Thank you.